Hello my dear ones. So far we are saying about the design aspect. Whenever we are looking into the design aspect or methodology of solving, we are talking about choose the best data structure. So here we are going to know what are all the data structures available, then only we can choose the one best suitable for the problem. So that is a discussion we are going to have here. So on the whole, we are going to learn about the basics of data structure and why we need it and what are the types of data structures available and abstract of it. So the data is information, data structure is the way of organizing that I have said in many places. There are different way of organizing the data. So in such a case, the data may be according to the problem, the data may be a single data or it may be a group of data or it may be in a file format or it may be in a well structured data structure format also, that is from a table format. That is and all to your view. Whatever you are seeing is different, how the system is internally storing is different. Here whenever you are talking is about the data structure is that is about the internal storage, how the system internally stores that data in order to maintain that efficiently. Okay, that is what why we need it for these three things, that is efficient access, because everything you are storing is for a future reference. So that has to be easily accessible. You no need to wait for a long duration or even in some problems and all, the data have to be retrieved in a very quick manner. The user want data immediately, within a nanosecond they need. So how fast the data can be retrieved back in one particular arrangement. So that is the first thing it is going to decide on about the data structure. The second one is reusability. Because one way of arrangement have to be used for the next time also. You no need to do the rearrangement again and again. That is not a good way. Whether the particular data structure is reusable for the next set of data or whenever the new data comes in. Then the third one is the abstract level, that is the internal storage, because the externally we will be viewing the data as a table format, internally system may be using in a different format. So that is a hidden one, how internally implements is not known to the user, that is an abstract view. Okay. Then when we are classifying the data structure broadly, that can be classified as primitive and the non-primitive. Primitive is based on inbuilt data type. Whenever you are implementing any of the algorithm into the real programming language, the programming language will give certain type of data allowed. So in such case, for example, if you are taking a C or a C++, even a Python, Python you can assign anything, but when I take a C or C++, it is allowing the primitive data types. Even a Python also having the primitive and the other will be of a derived kind. So in such a case it will be a numerical or it may be a character or it may be a string. So those and all coming under the primitive category, the data type allowed by the programming language itself. So from that base we can derive into something, that is going to be the next stage. So all that basic data type provided by the language is said to be a primitive. The next comes the non-primitive. The non-primitive is taken in order to have the collection of data. The single data will never, it's not be that in many of the complicated problems, single data will not be the one and only input to the problem. There is a need of multiple data to be handled. So all that have to be put together, that have to be grouped. The group has to be referred as a single unit. So in such a case, we have to go for the next level of data structure, that is coming under the non-primitive. So when you are classifying that non-primitive, that is said to be a linear and non-linear. Linear is one next to the other, it go only in an order. Refer first, go to second, from second go to third, from third go to fourth, like that it will be in a continuous sequence. So such a type of arrangement is said to be a linear data structure. So there we are referring it as of a array, list, queue and stack. Even in a linear, even in a sequence arrangement, there are different categories. Why it is, if you are taking that is a restriction to differentiate. If you want to have the similar type of data, similar type of group of data in a sequence, we have to go for an array. And if you want to have a similar, but in that case of array, we can access anywhere through the index position, that is allowed. But when you are going for a stack, that can have a that you can implement with a different based on the programming language. If you are going with the stack, you can access only the element on the top. If the data may be a similar one. If you are implementing array using that, definitely the data have to be similar one. If you are implementing a stack with a list, you can combine the data structures also. In such a case, it can be heterogeneous data, but it is allowed to access only the top element of the stack. So in such a way that differs. But in the case of list, you can travel to the next element by traveling from the first element one to the next, that is in a linked order. Where if you want to refer to the second element, you have to cross the first element. So likewise you can have, but the single list can have a group of primitive type also, that is allowed. Then a queue, it is like a normal queue. So the one which is on the front can access, the newcomer can be added to the last. Such a arrangement should be there in a data also. The one which is on the front can be accessible whenever the new data comes into that particular list, that should be added to the last. That arrangement is said to be a queue. Then next comes the non-linear. It is not to have one after the other. We can have a different arrangement also. There comes two data structures, one is tree, other one is graph. Tree, you all know that like a tree, it is having here it is going to be a top to bottom, like when you compare with a real tree, it is going to be the top to bottom, bottom to top. It is going from the root and a branch like that. Okay. So, but here we will be having a root on the top and the branches. But in a real tree, the root is on the bottom and the branches go up. So, it is upside down of the real tree, that is all. But all the components are here also. The root is there, the root node, the single root node, from that you will be having many branches, all that happens. Okay. That is the root. That is a tree type of data structure. A root will be there, the root below to the root, many branches, 2 branches or the number of branches, in such a way the tree outside can be classified. If there are only 2 branches, the binary tree. It is of 3 branches, that is a ternary tree. Like that we can classify based on the structure. If one root is going to have only 3 branches, if the one root is restricted to have only 2 branches. So in such a way we can decide a classification on a non-linear tree. The next comes the graph. Graph, here also it have a nodes, here also it will have a connected nodes, but it can form a cycle. One node can be connected to the other. Okay. For your more understanding and clarity, I draw the tree and a graph. So first let me see how the tree looks. So it will be having a root. I'm talking about tree now. So it will be having a root, and below to that it will be having a branch. So the below branch will have a node. This is said to be a node. Okay. That can have another branch, like that it will go. If there is no more branches, the last node is said to be a leaf. You will be learning all that in detail when you are completely studying about the tree data structure. Okay, just to have these terms alone in your memory: root, branches, nodes and all. Okay. So in such a way, we can have one more branch also. If there are only 2 branches, the name is different. If there is 3 branches, that is different. You can have n number of branches also. Okay. When comes into the graph, that is also having a node like this, nodes, and that are connected with the edges, and that go on like this. But here also it is having, when you tilt it to the straight, it is also looking like a tree only, but in this case the possibility is it can have the loop. The graph can have a loop structure like this. When you compare with the tree and the graph, this is the only different. This is also having a node, it is also having a branches. There we are calling it as a branches, here we are calling it as a vertex and nodes or edges like that. But there is a possibility of having a loop. And in a graph we can have a direction also. Direction also restricted. You can apply the direction. We can restrict it to the directed graph. So this is possible, but in a case of tree that is not possible. This is a different. Okay. So these are all the data structure. We have to choose one among this to implement a data arrangement for your algorithm. Let us look into the abstract data type. Abstract in the sense that is going to be the hidden information. The internal structure of storage or internal storage methodology will not be known externally. Only the abstract view will be given. That is said to be an abstract data structure. Even if you are using an array, we doesn't know how that is internally stored by the system. That is not known. So that is said to be abstract. So list can be an abstract. Then stack can be an abstract. Queue can be an abstract. Okay. So the abstract view, internal structure is hidden. The externally we are restricting to our particular algorithm, the data should be arranged like this. Okay. That is about the abstract data types. So these are all the data types you will be using in a problem solving when you are writing an algorithm to the problem, and also that we are going to learn in detail about how these data types work, how to access the data, how to retrieve the data, how to store the data in it. All that you will be learning in upcoming modules with the more detailed explanations also. So all that is going to be the intro session. You can have, you can think of that this is an intro session for all that details you are going to learn, but you are going to put all that together to solve a problem, because the algorithm can go only along with the data structure. So when you are choosing the data structure, you have to look into all these types to choose the best one. Okay. I hope you got better idea about what all the data structures available. We are going to make use that in detail. Thank you.